Okay, so continuing where we left off, remember that the goal for all of our statistical studies is to make sure that we make an inference about our population. So that's where we want to look at things, make that what we consider like a leap of faith of based on what all the information we got from the sample, we want to make this inference to the population. And so that's where the margin of error and the confidence interval comes into play. So if we look back at our document here, or our survey here, we'll see that there is in the methodology, so we can look through all of this, try and find the margin of error, and it doesn't, sometimes it's within one of these graphics, sometimes it's within the reading itself, but most often you can find it in the methodology that the particular study gives us. So in our methodology, it tells us kind of how they recruited all these people initially. And they talk a lot about how they came up with their sample, what was their questioning, if there was any incentives, if there was any people that did not necessarily participate for whatever reasons. And so this methodology gives us a lot of different information. And then down here, this is almost at the bottom of this particular page, is where we come up with this margin of error. And so you'll see here, this information gives us what's most important for us in terms of margin of error. So a margin of error is something that is plus or minus. So we're looking at things that are between, so a margin of error is a plus or minus a certain percentage. So let's suppose that one of our pieces of information was, say, 25% of the sample said something. We're not, whatever that happened to be. So that comes from our sample statistic. Okay, so if the margin of error is, say, 3%, plus or minus, let me rewrite this in the correct order, it would say plus or minus 3%. So that means that this confidence interval is 25% minus 3% and 25% plus 3%. So the confidence interval is going to be between 22% and 28%. This is where the population will fall. So once we use this confidence interval, now we're talking about the population. We know what the sample says, 25% of the sample said something. We again want to know what the population is going to say. So the population would be anywhere between 22% and 28%. One thing to take note, we want margin of errors to be no greater than 2.5% for a good assessment of the population, or a good inference to the population. And the reason for that is if this number is any bigger than 2.5%, this interval becomes wider and wider, and therefore we can't really make a lot of conclusions about the population. So if this was 5%, we would say that this is now a 10% interval, and we don't have a lot to say about that. So let's suppose we had one candidate that had 45% of the vote, so of the sample vote, and we had another candidate that was maybe at 49% of the vote. And so we can kind of put this on a number line, and let's say that the margin of error is plus or minus 5%. So that means candidate 1, this first candidate, would be anywhere between, say, let's go, here's 40%, here's 50%, here's 60%, just for the sake of a rough. So this candidate would be anywhere between 40%, the population would be anywhere between 40% and so 40% so 45 minus 5 is 40%, 45 plus 5 is 50%. So that would be, that's the population. Okay, but then with the second candidate, 49 minus 5 is 44%, all the way up to 54%. And so, as you can see here, there's a lot of overlap. And so we can't really determine if there's going to be one candidate would win over the other one because of so much overlap here. So the smaller this margin of error, the better we know whether our population, where our population is actually going to fall. Therefore, we can make better conclusions based on that. That's why we're really looking for no more than 2.5% in terms of a good margin of error. So when you look at polling, a lot of polls are coming out currently. A lot of them will say plus or minus 3, 4, and 5%. And they're making projections already based on that information. But there's a lot of give and take, if you will, when our margin of error is too large. All right. So now the other thing we want to talk about is this population parameter. Oh, then one other thing I want to note. Remember we said that our sample was broken into Hispanics, was a subgroup to the total sample. So the total sample, its margin of error is 1.7%. So plus or minus 1.7%. Remember that, and that was the 7,647 people. Total Hispanics, remember there was only 3,000 of them. That margin of error is a little bit higher. And so we can see that we can make projections based on the Hispanic population. We can make inferences based on the total U.S. adult population versus the U.S. Hispanic population versus the U.S. Hispanic registered voter population. But notice that we are getting larger and larger margin of errors here. The other thing you want to take note is all of our inferences are going to be at a 95% confidence level. That means, so let's go back to our situation here. Let's say that this was 25% of people indicated they want a 4-day work week. Let's say that's what we were talking about. So now the population parameter, the statement that we need to write here is, and it's a generic statement. It's always going to be the same statement with 95% confidence. Between 22% and 28% of, now we're talking about the population, all U.S. adults would like or are in favor of a 4-day work week. This is how all of your population parameter statements will look like, or the meaning of the confidence interval. So this can either be a population parameter statement, or it can also be the meaning of the confidence interval.